Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practical 1 Volumetric Analysis. In the present module, we are discussing experiment number 11, determination of alkali content in antacid tablets. The contents of this module mention about antacids, aim of the present experiment, principle behind the experiment, reagents required for the experiment, experimental procedure which comprises of three parts. First one, preparation of standard sodium carbonate solution. Second part, that is standardization of HCl solution, and the last part, estimation of alkali. Finally, results of this experiment. First part, antacids. You are familiar with the compounds used to relieve the acidity. Antacids are very common type of medicines used to relieve from acidity problems. Now we can have a discussion on common antacids. Antacids are basic or alkaline substances used to neutralize excess stomach acid, that is hydrochloric acid, and relieve symptoms of acidity, heartburn, and indigestion. Now, antacids react chemically with hydrochloric acid present in the stomach to form salt, water, and sometimes carbon dioxide. Common antacids contain sodium bicarbonate, magnesium hydroxide, or aluminum hydroxide as alkalis. Suppose the antacid contain sodium bicarbonate as the alkali. When it reacts with hydrochloric acid of the stomach, sodium chloride along with the carbon dioxide is produced. That's why we mentioned here, during the reaction of antacid with the HCl, there occur the formation of salt, water, and sometimes carbon dioxide. Now, these compounds, that is the bases present in antacid, neutralize excess stomach acid HCl based on the following reactions. First of all, if the alkali content include sodium bicarbonate, it neutralizes HCl as NaHCO3 plus hydrochloric acid gives sodium chloride, carbon dioxide, and water. If the antacid has magnesium hydroxide, it neutralizes the stomach acid hydrochloric acid by this equation, that is MgOH twice plus 2 hydrochloric acid gives MgCl2 plus 2 molecules of water, and the base present in antacid may be aluminum hydroxide also. If aluminum hydroxide is the base, it neutralizes the hydrochloric acid as AlOH thrice plus 3 hydrochloric acid produces aluminum chloride AlCl3 plus 3 molecules of water. So, it is very well clear that the antacid may have NaHCO3, MgOH twice, or AlOH thrice as its components. These basic substances present in the antacid neutralize the stomach acid HCl by various reactions as depicted here. Now, by titrating a known amount of dissolved antacid tablet with a known strength of hydrochloric acid, the amount of alkali can be determined. That is, the alkali content, the total alkali content in a commercially available antacid can be estimated by volumetric analysis, and it involves the titration of the antacid, a definite quantity of antacid dissolved in a solution with a fixed or known strength of hydrochloric acid or a standardized solution of hydrochloric acid. Now, aim of the present experiment. The aim of the experiment is to determine, to estimate the amount of alkali. Usually the alkali may be sodium bicarbonate, magnesium hydroxide, or aluminum hydroxide present in commercial antacid tablet, and for this experiment annular sodium carbonate crystals and n/10 hydrochloric acid solution. So, in order to estimate the amount of the total alkali content present in a given antacid tablet, you are provided with these two important reagents, nothing but annular sodium carbonate crystals and n/10 hydrochloric acid solution. So, you have to utilize the last two reagents to estimate the total alkali content in the given antacid tablet. Now, the principle behind this experiment. Annular sodium carbonate crystals, Na2CO3 crystals, can be used to prepare a standard solution. This is possible because sodium carbonate is a primary standard, and by using that standard solution of sodium carbonate, hydrochloric acid can be standardized, and for this titration we are using methyl orange as the indicator. The indicator is selected as methyl orange because you are performing the titration between a weak base sodium carbonate and a strong acid hydrochloric acid. For that titration, the suitable indicator based on the pH range is methyl orange. Now, the reaction responsible for the standardization of hydrochloric acid with the annular sodium carbonate crystal lies here. Na2CO3 solution reacts with the hydrochloric acid, or Na2CO3 plus 2 HCl gives 2 NaCl plus H2O plus carbon dioxide. From this equation, we can arrive at the fact that the equivalent mass of sodium carbonate, which is a weak base, is equal to half of the molar mass. That is, sodium carbonate is a weak base and its equivalent mass will be half of the molar mass. The molar mass will be equal to 106 just divided by 2, that is equal to 53. And using the standardized hydrochloric acid solution, the total alkali content or alkali present in antacid tablets can be estimated. Accurately weighed a fixed quantity of antacid and made up to a known volume, and titrate a fixed quantity of that with standardized HCl. The following reactions occur during titration of antacid with standardized HCl. NaCO3 present in the antacid content reacts with HCl like this. NaCO3 plus HCl produces NaCl plus carbon dioxide plus water. MgOH twice plus 2 HCl gives MgCl2 plus 2 H2O. ALOH thrice present in the antacid tablet reacts with HCl like this. ALOH thrice plus 3 molecules of HCl produces AlCl3 plus 3 molecules of water. Now, the end point of the titration of antacid with the standardized HCl will give the volume of HCl required to neutralize the alkali present, the total alkali present in the antacid. The milli equivalence of HCl consumed will be same as the total milli equivalence of alkali present in the antacid. Thus, it is possible to estimate the milli equivalence of alkali present in the tablet, in the antacid tablet, or how much milli equivalence of alkali are available per tablet of the given antacid can be estimated. Now, reagents required for the present experiment. The reagents required are annular sodium carbonate crystals, approximately n/10 hydrochloric acid solution, antacid tablets for estimation of alkali, methyl orange indicator for performing the titration reactions, and these reagents are required for the present experiment. Now, experimental procedure. I already mentioned in the introductory part that the entire experimental procedure has 3 parts. The first part being the preparation of standard sodium carbonate solution, and the second part involves the standardization of the given HCl, and the final part is the estimation of antacid. We are now entering into the procedure of preparation of standard sodium carbonate solution. As you know, sodium carbonate is a primary standard, mass of sodium carbonate required to prepare 100 ml of n by 10 solution can be calculated by using the expression weight required equal to VEN divided by 1000. As you know, V represents the volume, which is the required volume. In the present case, it is fixed as 100 ml. So, V is equal to 100 ml. E stands for equivalent weight of sodium carbonate, that is equal to 53. Just multiply with the required normality N, that is 0.1, and the whole thing should be divided by 1000, and we will get the weight as weight required equal to 100 into 53 into 0.1 divided by 1000. You will get the weight required equal to 0.53 gram. Thus, if you are weighing out 0.53 gram of sodium carbonate accurately and made up to 100 ml solution, you will get a sodium carbonate solution with the concentration 0.1 normal. Now, moving on to the further experimental part, roughly weigh out 0.53 gram of AR sodium carbonate crystals and transferred it to a dry weighing bottle. It is then weighed by electronic balance as the weight W1. Remember, the weight W1 is the total weight of the weighing bottle and sodium carbonate. This substance, that is sodium carbonate present in the weighing bottle, is now transferred to a 100 ml standard flask or volumetric flask through a funnel and made up the solution to mark. That means you have to prepare 100 ml solution by using this weighed out sodium carbonate. Now, the weight of the empty weighing bottle is again taken by the electronic balance and it is recorded as W2. Thus, the actual weight of sodium carbonate taken will be equal to the difference in weight, that is W1 minus W2. W1 is the weight of weighing bottle plus sodium carbonate. W2 is the weight of empty weighing bottle. So, W1 minus W2 gives the actual weight of sodium carbonate taken in the experiment. This weight, that is W1 minus W2, is used to find out the concentration of the prepared sodium carbonate solution as normality equal to weight per liter divided by equivalent weight. So, from the weight taken, you can find out the weight per liter. Just divide that weight per liter with equivalent weight, you will get the normality of the prepared sodium carbonate solution. Now, the standardization part of HCl, that is the second part of the experiment. We are discussing the procedure behind the standardization of HCl solution, and for the standardization of HCl, here also we are using conventional titration procedure apart from the two burette titration method, and for this purpose 20 ml of the standard sodium carbonate solution is pipetted out into a conical flask. Add 2 drops of methyl orange, which is suitable for the titration of sodium carbonate with HCl. Then add 2 drops of methyl orange indicator, and this solution is titrated against HCl solution taken in the burette. The end point of the titration is exactly the color change from golden yellow to orange red, that is the color change of methyl orange indicator. Now, you have to repeat the titration for concordant values. That is, you will get the concordant value, which is the volume of HCl used in the reaction. Now, standardization of hydrochloric acid solution demonstration. Over to the experiment. We are now demonstrating estimation of total alkali content in an antacid. For this purpose, we are taking a definite quantity of antacid and prepared it into a solution of definite volume. And this experiment also has 2 parts. In the first part of the experiment, we are going to standardize the hydrochloric acid solution, and the standardization of hydrochloric acid solution is made by titrating the hydrochloric acid solution with a standard solution of sodium carbonate. So, first part is the standardization of hydrochloric acid. In the second part, we are estimating the alkali content present in the antacid by titrating with the standardized hydrochloric acid solution. So, we are now entering into the first part of the experiment, that is standardization of hydrochloric acid using a standard solution of sodium carbonate. Over to the experiment. Now, part of the standardization of hydrochloric acid solution, and now we are focusing the calculation part. The weight of sodium carbonate taken, that is the difference, which is equal to W1 minus W2, and that is equal to 0.5312 gram. Now, weight of sodium carbonate per liter is equal to 0.5312 multiplied with the 10. Here we are multiplying with the 10 because of the fact that you prepared a 100 ml solution. So, weight per liter is obtained by multiplying this quantity with the 10 to get weight in 1000 ml. Weight in 1000 ml is the weight per liter, that is equal to 5.312 gram. Now, normality of sodium carbonate solution is obtained as normality equal to weight per liter divided by equivalent weight, and weight per liter is equal to 5.312 gram, which is divided with the 53, that is the equivalent weight of sodium carbonate. You will get the normality of the solution as 0.1002 normal. Now, you already performed the titration between sodium carbonate and given hydrochloric acid, and the titer values of that titration is already tabulated like this. This is the titration Na2CO3 against HCl. The volume of sodium carbonate pipetted out in 3 consecutive titrations will be equal to 20 ml, and you got the concordant value, that is the volume of HCl used, equal to 20.2 ml. That is 20.2 ml is the volume of HCl which is required to neutralize 20 ml of the already prepared sodium carbonate solution. We can continue the calculations. From the titer values, we can calculate the normality of hydrochloric acid using the relation N sodium carbonate into V sodium carbonate equal to NHCl into VHCl. This is a more specified form of the volumetric equation N1 V1 equal to N2 V2. So, in the present expression, N sodium carbonate, that is we already calculated during its preparation, which is equal to 0.1002 normal. Then volume of sodium carbonate, that is the volume of the solution pipetted out, which is equal to 20 ml, and volume of HCl, that is a concordant value in the present experiment, that is equal to 20.2 ml. Based on these values, on substitution in the above equation, you will get the normality of the given HCl solution as 0.0992 normal. That is the normality of the HCl solution. Thus, by this part, we have standardized the given HCl solution by using a standard solution of sodium carbonate. Now, the last part of the experiment, that is estimation of alkali. We are now discussing the procedure behind the estimation of alkali. For this part, for the experimental part, take one antacid tablet, powdered it well and weigh out about 300 milligram accurately. So, a commercially available antacid may have a different weight. From that weight, for the sake of convenience, we are weighing out 300 milligram of the alkali, 300 milligram of the antacid tablet. Now, this is transferred to, this weighed out antacid is transferred to a 100 ml standard flask and made up to the mark using distilled water. Remember, we have to use distilled water for this experiment. The solution is shaken well to get a uniform concentration, and from this pipette out 20 ml into a conical flask and add 2 drops of methyl orange indicator. The solution is then titrated against the already standardized hydrochloric acid solution taken in the burette to determine the end point. The end point of the titration is the color change of methyl orange, that is from golden yellow to orange red. Finally, you have to repeat the titration to get the concordant values. We are now demonstrating the estimation part of alkali content in antacid tablet. Over to the performed the experiment and now entering into the calculation part. The titer value can be tabulated like this. The titer value during estimation of alkali content can be tabulated like this. This is the titration. Antacid against standardized HCl. Volume of antacid solution pipetted out in 3 consecutive titrations will be equal to 20 ml. These solutions are titrated with the standardized HCl taken in the burette with the titer values 18.4, 18.3 and 18.3. From this chart it is clear that 18.3 is the concordant value of the titration. That is, the volume of HCl required to neutralize a certain prepared volume of antacid solution will be equal to 18.3 ml. Now, from the titer value, we can estimate alkali content by the following set of calculations. For this purpose, number of milli-equivalents of alkali is taken as number of milli-equivalents of acid. This is the very underlying principle behind the acidometry and alkalimetry part of volumetric analysis. That is, in acidometry as well as alkalimetry, we are neutralizing acid or base with the opposite substance. So, the milli-equivalents of alkali must be same as milli-equivalents of acid. Milli-equivalent is a quantity obtained by multiplying normality with the volume in ml. If normality is multiplied with the volume in liter, you will get equivalence. If you wish to get milli-equivalence, you have to multiply normality with the volume in milliliter. So, it is very well clear from the volumetric equation that N antacid into V antacid. N antacid into V antacid equal to N HCl into V HCl. Remember, N antacid is the normality of antacid and V antacid is the volume of antacid in ml. So, the left hand side represents number of milli-equivalents of alkali content in antacid. That is same as NHCl into VHCl. That is number of milli-equivalents of HCl. So, number of milli-equivalents of HCl will be same as number of milli-equivalents of alkali content present in the antacid. NHCl, that is normality of standardized HCl, we got as 0.0992 normal. And we also got the volume of HCl from the concordant value as VHCl equal to 18.3 ml. So, the quantity normality of HCl multiplied with the volume of HCl is the number of milli-equivalents of HCl. The number of milli-equivalents of HCl should be same as number of milli-equivalents of alkali. This made the evaluation of number of milli-equivalents of alkali possible. So, remember the expression milli-equivalence is calculated as normality into volume in ml. We got the normality of HCl as 0.0992 normal and volume of HCl equal to 18.3 ml. So, NHCl into VHCl will be equal to 0.0992 multiplied with 18.3, that is equal to 1.8154. That is milli-equivalence of HCl which is required to neutralize alkali content in the taken volume of antacid will be equal to 1.8154. Based on the theoretical part, it is very well clear that this milli-equivalence of HCl, that is 1.8154 milli-equivalence of HCl is same as the milli-equivalence of alkali content in the antacid. That is, the milli-equivalence of alkali is same as 1.8154. Thus, milli-equivalence of alkali in the whole of the given solution is equal to 1.8154 into 100 by 20. Now, the question arises, why we have to multiply with 100 by 20? Remember, you are preparing this solution or weighed out antacid tablet is prepared into is converted into a 100 ml solution, from which you are pipette outing only 20 ml. So, milli equivalence of alkali in the whole of the 100 ml solution you prepared is equal to 1.8154 into 100 divided by 20. This milli equivalent is present in 20 ml. So, number of milli equivalents in the whole of the given whole of the solution of 100 ml will be equal to 1.8154 into 100 by 20. Hope this part of the calculation is very crucial and it is very well understood by you. Once again I repeat for the sake of the convenience, 1.8154 is the number of milli equivalents of alkali present in 20 ml, that is you pipetted out. But you made the solution previously into 100 ml. So, to get the milli equivalence of alkali in the whole of the given solution of a volume of 100 ml, you have to perform this calculation. And you got the milli equivalence of alkali in the whole of the given solution is 9.077. Now, milli equivalence of alkali is 9.00077. This milli equivalent is present in 302 milligram of antacid, because we already weighed a quantity of antacid and that is equal to 302 milligram. This weight is the weight we obtained during the experimental part. Instead of getting sharp 300 milligram, we weighed out a quantity that is equal to 302 milligram. So, the milli equivalence of alkali present in 302 milligram of antacid equal to 9.077 milli equivalent. Milli equivalent of alkali per tablet is the next part of the calculation, and in the alkali in the antacid tablet, the weight is marked as 600 milligram, and now we are going to find out milli equivalence of alkali present in a particular tablet. The tablet is having a weight of 600 milligram. We performed the entire calculations by weighing out 302 milligram of antacid. So, we have to transform this milli equivalence into the milli equivalence per tablet, that is per 600 milligram. For that, you have to perform this calculation. 9.0072 is the milli equivalence per 302 milligram. Just to multiply with 600 milligram, that is the actual weight of the antacid tablet, single tablet. You got the number of milli equivalents as 18.03. So, 18.03 is the value of milli equivalence of total alkali present per antacid tablet. Now, the final result of the experiment. Alkali content per antacid tablet equal to 18.03 milli equivalents. Thus, we have evaluated the alkali content per antacid tablet by this experiment. Have a nice learning experience. Thank you.